Uh, okay. Hello, everyone. For today, we're gonna do a new unit. It's called trig formulas. Basically, is around the knowledge that we learned before, which is the trigonometry, like sine, cosine, tangent. But it's more like harder for this time. But after you like remember all the formulas, I think you will be great. So yeah, let's get started. Roger, you can go right now.
Okay, so we'll start from reviewing some basic trigonometry. So we need to recall the sine, cosine, and tangent we learned before. Sine theta means it is the opposite edge divided by the hypotenuse, and cosine is the adjacent edge divided by the hypotenuse, and tangent is basically the opposite edge divided by the adjacent. It is also known as sine divided by cosine. All right, so here are some other properties of sine, cosine, and tangent. So they have their uh, kind of inverse operations like cosecant means 1 over sine theta, secant means 1 over cosine theta, and cotangent means 1 over tangent theta, and vice versa. It also works if you when you want to get sine, cosine, and tangent. And the most basic formula we learned is that cosine square plus sine square equals 1. And from this property, we can get sine secant square equals 2 plus tangent square. So how do we exactly find this? Is that uh, it's like this. Wait a minute. So secant square is actually 1 over cosine square. So it equals 1, which is cosine square over cosine square. And tangent square is actually sine square over cosine square. And we know cosine square plus sine square equals to 1. So we can rewrite this whole thing as 1 over cosine square. So that's how we get this formula. And the second formula is similar, which is cosecant theta equals to 1 plus cosecant theta square equals 1 plus cotangent theta square. So cosecant theta square is actually 1 over sine square. And the rest are the same as this. So we know these basic formulas for cosecant and secant. It will help us solve more subtle questions. So we can continue to the next slide.
Okay, so this is 2 practice questions. So just pause the video and try to do it by yourself. Okay, so for the first problems, we need to simplify this expression. So first we need to review our formula. So 1 minus cosine square theta equals to sine square theta. 1 over sine square theta. Then after we get this one, and we know that the cosecant theta equals to sine 1 over sine theta. So which means this expression equals to this, which is the cosecant square theta. And for the second one, equals to, first we can simplify it into the sine square theta. Sine square theta. What? Okay. Then we will keep the denominator, which is sine theta times cosine theta. Then we can cancel out the sine theta, which will result in this sine theta over cosine theta. And this is the solution of these two practice problems. So next slide. Wait. This is a more detailed solution of these two questions. So if you need it, just pause the video and take a close look at it. Next slide, please.
Winston, go ahead. William, you can go.
All right, so this slide is more formulas. We just learned a few of them, now there's more. For sine and cosine only this time. 4 formulas. First one is sine of a plus b is equal to sine a times the cosine of b plus the cosine of a times the sine of b. So this is for addition inside of the parentheses. Then for subtraction inside of the parentheses for sine, which is sine of a minus b, that's equal to sine of a times the cosine of b minus the cosine of a times the sine of b. This looks like a jumbled mess, so we can dissect it a bit. There's sine a here, cosine a here, and then cosine b here, and then sine b here. And it's same for minus, right? Except for the minus sign in the middle. So sine of a plus b has a plus sign in the middle, and sine of a minus b has a minus sign in the middle. Cosine is slightly different. So we look at cosine of a plus b, which is equal to cosine of a multiplied by cosine of b, minus sine of a multiplied by sine of b. And cosine of A minus B is cosine of A times cosine of B plus sine of A times sine of B. So don't know why one of them is blue, but these have a pattern as well. You see cosines on one side and sines on the other, right? For cosines, cosines are all on one side, sines are all on the other. And same for A plus B and A minus B. There are always cosines on one side and sines on the other. And then this is a bit more confusing than before. You see cosine of A plus B, there's a minus sign in the middle, and cosine of A minus B, there's a plus sign in the middle. That would be the that would be the two differences between these, the ones that cosine, the ones that are sine. And I think we can go on to the next slide.
Oh, Gavin, you can go. Never mind. William, you can go ahead and do like 3, I think.
Sure, let's do that then. Okay. Let's try doing this. So we have 3 problems here. Sine of, I should circle this. That's not good. This one right here, this one right here, and this one right here. 1, 2, and 3. So take this time, pause the video, and try to solve them. And once you are finished, come back and I will show some solutions. Okay, let's see. How does this relate to the earlier formulas?
Like you split into 2 degrees, like 180. Let me. Yeah. We can do like 180 and negative 45. Well, no, like negative 180 and negative 45. Let's. Yeah, so you do sine negative 180 plus negative 45, and then bring your numbers in.
But that doesn't actually equal 255.
Shoot, really?
So it's split into 220, negative 225 and negative 30, I think.
Well, it is, right? Like negative 180. Yeah, negative 180 plus negative 45 is negative 225. Well, like, I think when I learned this, like, the basic goal is to match with a unit circle. That way you can, like, you know. Well, yeah, you can go. You can just like do your ways.
Okay, sure. Because the problem is negative 255, not 225. So
Oh, never mind. Yeah, sorry.
so we use wait, negative 225. Wait, okay, so we we can do it this way. So we want to use the formula sine of, this is gonna be a bit ugly. Sine of a plus b is equal to a bunch of different things, right? And what we have here is negative 255, which here we probably want to split into two different, actually, hold on just a second. Okay, so you can split that into negative 225 and negative 30. Negative 225 and negative 30, which then you just plug into the formula from earlier, right? So sine of, that disappeared. Did that disappear? That did not disappear. Okay. Sine of negative 225 times the cosine of negative 30 plus the sine of negative 30 plus multiplied by the cosine of negative 225. There we go. Negative 225. Okay. And then you just want to use some identities from, not identities, some values from the unit circle in order to solve this. So sine of negative 225, sine of negative 225 is equal to, this is most easily done by probably remembering it. We don't happen to have a unit circle right now. So sine of negative 225 is 1 over root 2. 1 over root 2. And cosine of negative 225, I shouldn't have done this here. Okay, that's fine. And then cosine of negative 225, cosine of negative 225 is, cosine of negative 225 is equal to negative 1 over root 2, right? Oh, that's very bad. Negative 1 over root 2. Okay. Then we look at negative 30, sine of negative 30 and cosine of negative 30, cosine negative 30. So sine of negative 30, negative 30 is equivalent to negative 1/2, and cosine of negative 30, cosine of negative 30 is equivalent to root 3 over 2. I believe that should be correct. So now you have the 4 values we need. This one, this one, this one, and this one. Once you have these, you can just plug that into this part, right? Substitute those into this part. So I will do some erasing. Actually, I don't need to. You can just say sine of, right, negative 255. 255, that's equal to, first one, sine of negative 225, which is 1 over root 2. 1 over root 2. That is multiplied by cosine of negative 30, which is root 3 over 2. Root 3 over 2. Added on to sine of negative 30, which is negative 1/2. Negative 1/2. and multiplied by cosine of negative 225, right? Which is negative 1 over root 2. So I will assume you guys know how to simplify radicals, so I won't do that here. Instead, the answer to sine of negative 255 is, once you multiply all of those out, you get 1 plus root 3, 1 plus root 3 over 2 root 2 over 2 root 2. And that should be your answer. It's a bit messy and a lot of work, but in the end, you do get a relatively nice radical. So 2 more. This is gonna take a while. I'll erase this one if you need it. Since this is a video, always pause and come back and you can look at it a bit more. Okay. Next one seems a bit more complicated. You can just clear the board. There we go. I know how Zoom works. Okay. Tan of 11 pi over 4. I will assume 11 pi over 4 is in radians and not degrees. So we have no formulas of tangent. Well, that's fantastic. Sine over cosine time. Tangent should be equal to sine over cosine, unless I messed that up. Yes, okay, good. So we have tangent of something, right? Tangent of theta, let's use theta. But then that's just equal to sine of theta over cosine theta. We learned this earlier. I'll just write it down here. Sine of theta over cosine theta. Now, we haven't learned any formulas for tangent addition of sum of angles in tangents, sorry. So we can split them into sine and cosine and do the division. More work, love it. Okay, 11 pi over 4. We would like to, I'm going to erase this, you should know this already. We would like to split that into some better fractions, better radian fractions. 11 pi over 4, God, what should that be split into? Eight, think. Okay. 11 pi over 4. Wait, what? Um, 2 pi plus 3 pi. Okay, true. Yes, ha, that makes sense. 11 pi over 4 is 11 pi over 4. My brain doesn't work today. Over 4 is just equal to 2 pi plus 3 pi over 4. Right. Plus 3 pi over 4. There we go. That makes more sense. Okay. That disappeared again. That's okay. So we look at these two separately. We need sine of 11 pi over 4, which is just sine of 2 pi plus 3 pi over 4. I'll write the equation out, and then I won't do the simplification things. So sine, this is equal to sine of 2 pi multiplied by cosine of 3 pi over 4, I think, right? Cosine of 3 pi over 4. This is added to sine of 3 pi over 4. multiplied by the cosine of 2 pi. And then you can, if you didn't get to this step, you can take your time, try to solve this equation, and I will also try to figure out what that is. Okay. I'll write the answer down. So sine of 11 pi over 4, which is what this is, right? Sine of 11 pi over 4 is just 1 over root 2. So if you do the math, you will most likely find that this big thing will equal to 1 over root 2. So I will erase that and write it down. So sine 11 pi over 4 is just equal to 1 over root 2. Okay. Nice. And now we need cosine, because tangent sine over cosine, so we need cosine as well. Cosine of 11 pi over 4, 11 pi over 4 is again equal, you split it up. I shouldn't write it like this. You split it up into 2 pi and 3 pi over 4, like we did before. Cosine 2 pi and 3 pi over 4 plus 3 pi over 4. And you use the formula, which is cosine on one side, sine on the other. And because it's addition, here it's flipped, so there's a negative sign in the middle. So cosine of 2 pi, which by the way, 360 degrees, so just a full circle. Cosine of 2 pi multiplied by the cosine of 3 pi over 4, 3 pi over 4 minus, that's right? That is right, minus sine of 2 pi cosine of 3 pi over 4. I am pretty sure I'm right. Hopefully. Okay, sine. That's not cosine, that is sine. I'm very sorry. That's sine. Okay, and take the time to do those calculations. In the end, it should get you, cosine of 11 pi over 4 should get you negative 1 over root 2. Negative 1 over root 2. And then what we wanted was not sine and also not cosine. What we wanted was the tangent, right? So I'll clear this as, I'll clear this as well. So what we want is tangent of 11 pi over 4, which is just sine of that over cosine of that. So sine of that is 1 over root 2. And cosine of that is negative 1 over root 2. Do the division, you get negative 1, I think. My brain really doesn't work today. Negative 1, yes. So this problem is just negative 1. Okay, and finally, number 3. Tangent of 615 degrees, which 300 plus 315. Good, that worked. 300 plus 315. So 300 degrees plus 315 degrees. And we choose these numbers based on, am I not right? Wait, but 300 plus 315 works as well, right? Right? Okay. 360 plus 255 is maybe easier, maybe not. How would you do 255 though? We did that earlier, I guess. But okay, let's try 300 plus 315. 300 plus 315, that is equal to 615, right? That should be pretty obvious. And then we do the same as before. Since this is tangent, we want sine and cosine. So first is sine of 300 plus 315. Same formula as before, right? It keeps disappearing. Sine of 300 multiplied by cosine of 315, 315 plus sine of 315, 315 multiplied by cosine of 300. And this, if you calculate it, should get you a rather complicated radical, negative 1 plus root 3, negative 1 plus root 3 over 2 root 2, over 2 root 2. Negative 1 plus root 3 over 2 root 2 will be the answer for sine 300 plus 315, which is sine 615. Now we do cosine. I won't erase it this time, I space. So we have cosine of cosine 300 plus 315, right, is equal to cosine 300 multiplied by cosine 315. Remember, cosine formulas are different. Cosine 315 minus sine of 300. 300 and multiplied by sine of 315. Sine of 315. I did not end up fitting it, but that's okay. Sine of 315. Again, just directly plug into the formula, and in the end, your answer for cosine of 615 should get you negative root 3 minus 1, root 3 minus 1 over 2 root 2. Okay, so you have these two, and we now do division, which I will do on the left side. Sine divided by cosine gets you tangent, which is what we want. So we have negative 1 plus root 3 over 2 root 2 divided by negative root 3 minus 1 over 2 root 2. There's 2 root 2 on the bottom, right here and right here, so we can just cancel this out. We get negative 1 plus root 3 over negative root 3 minus 1. 3 minus 1 in parentheses and parentheses. Okay. Negative signs cancel out. Basic. That looks like a plus sign. Actually, that worked. So negative signs cancel out. We get 1 plus root 3 over root 3 minus 1. Which... Wait. Did I do something wrong? Yes, I did. Wait, did I? Okay, so we get this and 1 plus root 3 over root 3 minus 1. Hold on. Okay, right, that is correct. Sorry. And this can actually simplify to 2 plus root 3. That's why I got confused. Okay. This simplifies to 2 plus root 3. And that is your answer. Okay. 3 pretty complicated problems. They're not too difficult once you know how to do them. I don't really know how to do them, but we will stop there for these 3 in class as practice problems, and I think number 4, 5, and 6 down here, right? Number 4, 5, and 6 down here, you guys can do after watching the video as sort of practice problems. They're pretty much similar to these first three problems. They will use the same formulas that were on the previous slide. So you can just do these later. And I think we can move on to the next slide.
Roger, you can go ahead.
Okay, so here comes the double and half angles formula. So this is actually something that originated from the like angle addition formula we discussed before. So this is basically just basic. We basically say a plus b equals to a plus a. So here comes the double angle formulas. So sine 2a equals to sine a times cosine a, and cosine 2a equals cosine a square minus sine a square. So this formula can actually transform to 2 cosine a squared minus 1 and 1 minus 2 sines a squared. So these two formulas are actually originated. They apply the formula sine squared plus cosine squared equals 1. So from these two formulas, we can actually do something interesting. And the third one is tangent to a, which is two tangent a over one minus tangent a square. So actually, we need to talk about this. We need to talk about this tangent to a since we didn't. It seems like we didn't talk about the addition angle formula before. So tangent a plus b is actually tangent a plus tangent b over 1 minus tangent a times tangent b. So this is the double angle formulas. And if you change the 2a into a, and you change the a into a over 2, you can get the half angle formulas.
Ren, you can